Hi guys, how you doing? Hope you're well. So in this video we'll be covering linear IC regulators, which are just voltage regulators that come in this lovely little package. So in the previous video we actually created voltage regulators using Zener diodes and transistors. Now as with all modern day electronics, they make everything small and tiny, and so you can get even these things in even tinier packages like these. So yeah, this is a voltage regulator with quite a fair bit inside it. So what I've done is I've got over here a 7805. Don't think you can really see it on there. There we go. But trust me, it's a 7805. This little IC takes up to 40 volts DC, and then it outputs a solid 5 volts DC as well. So in case you haven't seen our last video on voltage regulators, here is the circuit that we used to create one using, we've got here a Zener diode here, a resistor in series, and then a transistor. And so this circuit here was effectively a very basic voltage regulator, which is what's inside here. Now in reality, what's inside here is actually a lot more complicated, and let's take a look at this schematic here. So this is this. What's all of this stuff here is inside this tiny little package here. And so you can see you got a bunch of resistors, you got some diode, you got transistors, capacitor. There's a lot going on there. Now I'm not even going to attempt to explain the schematic, but they do come with a block diagram, and as you can see here, we've got starting circuit, reference voltage, current generator, error amplifier, thermal protection, SOA protection, and series pass element with a voltage divider, and then you got your V out and ground. So all of these components here make up this block diagram here, which is all inside this tiny little IC here. So in terms of how it's used, you're usually going to find the IC sandwiched between two capacitors. So an input capacitor here and an output capacitor here. These are just to prevent any unwanted noise and to act like a filter, so you often see it like this. Alright, cool. So let me take a little bit of a step back. Before I dive into this circuit, which I'll show you how it works, I just want to touch on voltage regulator ICs just in general anyways. So in terms of IC regulators, what we do is we actually have 4 types. So 4 different types of these IC regulators. This one here is called a fixed positive IC regulator, or voltage regulator. What that means is that this IC here is going to take an unregulated DC voltage and it's going to output a fixed voltage that is positive. So in this instance, the 805 will output plus 5 volts. Super simple. The one thing to know here is that the most used series is this series here, which is the 7800 series. So if you're going to buy an IC, you're most likely going to buy this one in terms of voltage regulator. Now for the naming convention, they have 7, 8, and then the output voltage. So you got 7805, which is what we're using, and that outputs 5 volts. You got 7806, and that outputs 6 volts. 7810 outputs 10 volts. 7812 outputs 12 volts, and so on and so forth. The next type is the fixed negative, which is just the exact opposite of the fixed positive. What that means is that that's going to provide at the output a fixed negative voltage. So it's going to be minus 5 volts, minus 6 volts. This might be a bit confusing actually how I've put this here. Let me just do it like this instead. So you can see that equals 5 volts, 6 volts, 10 volts, and 12 volts. So the fixed negative, one of the most positive ones you'll see again is the 7900 series. And so as an example, you've got the 7905, and that's going to output a minus 5 volts. 7912 is going to output minus 12 volts, and you get it. Alright, next up we've got adjustable. So type 3 are adjustable. So this just means that they provide a variable output. So the opposite to fixed. What they do is they actually used a variable resistor. So they use a variable resistor to vary the output. So one of the most popular ones that you'll see there are the LM317, which I'm hoping to do a video on next. And that IC there, instead of the LM7800 or 7805 output in 5 volts, this LM317, it can output from 1.2 volts up to 37 volts. So it's a variable resistor, and you can set that output voltage using some external resistors basically. And lastly, the 4th type are dual tracking voltage regulators. Maybe let me just put this down here so it's easier to see. So 4th, dual tracking. This is a very interesting one, which I'm currently trying to learn about, but it's a little bit tricky. But basically what it does is it takes two inputs into the IC. So this is the IC here, a dual tracking voltage regulator. What it does is it takes two inputs, a positive input, let's say for example plus 20 volts, and it will take in a negative 20 volts as well, and then it will output both a positive and negative fixed voltage. So for example, you'd have plus 12 volts and then minus 12 volts. I don't really understand the use case for this, but apparently from what I read online, it is useful, so we'll just take Google's word for it, yeah? So in this video, we'll just be using the fixed positive one because we're just going to be using 5 volts and 10 volts and 12 volts to drive a motor. That's it. So keep things nice and simple. Once you're good with just the general what the voltage regulators are, there are some important things that you do need to keep in mind. Let's just do this in a different color. So we're going to put important. So the first thing we'll put A because I don't want to mess up with the different types. You need to make sure that your input voltage is greater than your output voltage or your desired output voltage. Just keep that in mind. You know, if you want 5 volts at your output, then you've got to make sure that you're supplying, for example, 7.5 volts at your input. Just make sure that's true. Okay, the second thing that you need to know and keep in mind is that these things have something called dropout voltage. I'll explain it with the example. This is a good example here. If you want 5 volts at your output, then what you need at your input is 5 volts plus a dropout voltage. So what that means is that that's like the difference or the smallest difference between the regulator's input and its output voltage. So it's the amount that the regulator needs in order for it to do its job, basically. And so what you're going to find, for example, with a 5 volt regulator, the regulator is going to need, for example, 2 volts, 2.5 volts, let's say 2 volts, in order to be able to do its job and regulate the voltage properly. So you're going to need to be providing 7 volts at the input or 7.5 volts at the input in order to get a nice solid 5 volts at the output. Again, you can find out what input voltage and what dropout voltage and etc. that you need for each of the different ICs just by Googling it and also checking out the data sheet as well. I just wanted to just quickly mention that here. So third thing, which you need to know, I know we all know about heat dissipation, so I'm not going to spend too much time on this, but I just want to mention it. So obviously heat dissipation is just when a device, an electrical device is producing heat. Obviously we don't want our device to be producing heat since that's a waste of electricity, and if you're running your circuit off of a battery, you're going to be losing a lot of energy, a lot of storage from your battery, just wasting it on heat. And the other thing is that obviously sometimes as these, or just all devices really, as they heat up, their performance suffers as well. So the thing to keep in mind with these is that as your input voltage goes up, then so will the heat of the device. In this instance here, I'm taking in an input, let's say for example 10 volts, and I'm using the voltage regulator to output 5 volts. So my voltage regulator needs to handle that 5 volts of extra waste, or be about 4 volts of extra waste. If I'm putting in 20 volts, then now it needs to handle 15, 14 volts of extra waste. And so if I input 10 volts, this probably won't be too hot. But if I input 20 volts, it's probably going to start to get quite hot. And then that's where obviously heat sinks come in. So I've got these, which I showed in another video. You just attach them onto there. I got them off Amazon. I think it was like 10 for £6 or something. It's a bit expensive, to be honest with you, just for a little bit of metal. But the thing to keep in mind, with BJTs, you're usually using a low current. But here, I was outputting 0.5 amp earlier, and this thing got super hot. So yeah, if you're going to be using it for high current applications, or you're going to be dropping a high amount of voltage across it, you're going to want to stick one of these on it. And that's it. That's all you need to know. So again, I do try to keep these things simple, so no maths involved as well, apart from a little bit of addition. All right, so let's get into the actual circuit. You know what? I've got the wiring diagram schematic here for this. Again, all we've got here is the 7805 plus 0.22 microfarad capacitor and a 0.1 microfarad capacitor. Again, these are here just to deal with noise and to act like a filter. So what I'm going to do is I'm going to supply my input voltage here into my input pin, and then my ground pin is just going directly to ground, and then my output pin is coming along here. So I'm going to tap into the output along here. So what I'll do is I'll just put this little motor and I'll attach it to my output like so. And then what I'll also do is I'll just attach 2 extra wires in order for me to just look at the voltage on the output using my multimeter. Okay, you know what, first of all, let's remove the motor. I won't put the motor, I'll just look at the output here. Alright, so now for the input, I'll apply my input here into VCC, positive rail, and then negative rail. Okay, let's crank the voltage up. Okay, so we've got no current flow because obviously I don't have a complete circuit here. But if I just go, I'll just go up to like 10 volts. There we go. Tell you if it's hot. It's not hot at all. Obviously no current flow. And then now I can just check the voltage. So we have 4.97 volts at 10.2 volts input, 4.96, 4.97 on the output. So I crank it up, go up to 16 volts, 4.96, go up to 21 volts, 4.96, 4.97. So the exact same voltage no matter what I change this to. So if I go, so I'm moving, I'm now at 5.4 volts. I do not expect that I'm going to get 4.96 at 5.4 now. Let's check. 4.23, there you go. So remember what I said, the input voltage needs to be higher than your expected output voltage. So I want 5 volts out. 5.4 is not high enough. If I go to 6 volts, I expect that it should be 4.9 now. There you go, 4.92. So it's not quite there, it needs to be a little bit higher. 6.5, we get 4.97. There we go, 4.96. And then it should be 4.96 all the way from there. There you go. It's a perfect voltage regulation. So what I can do is let me plug in the motor, but what I'll do first of all is I'll just connect the motor directly to my power supply so I can show you the change in voltage in the motor. So let's just okay, so here my motor is just directly connected to the power supply. Now what I want you to notice is watch how the motor changes speed. So I'll take it up to 5 volts. It's kind of like at its max there anyways. So 5 volts, listen to it. Now as I increase the voltage, you're going to see the motor is going to keep going faster and faster, and you're going to get louder and louder. Watch. Okay, so obviously my motor is not going to last very long like that. So let me now show you it like this using this lovely voltage regulator. And you're going to find that it's going to keep that 4.97 volts, that 5 volts constant. And my motor is going to be able to just operate steadily without going crazy. And this is what you think about when you think about a voltage regulator. You're thinking about the fact that no matter how the input voltage changes, your circuit on the output of the voltage regulator is just going to be sound. It's not going to have any problems. It's just going to carry on operating because it doesn't see the change. Can't even get this in. Your circuit on the output here doesn't see the change in voltage because your voltage regulator is dealing with it. So now look, it doesn't even turn on. It's not going to turn on. Oops, sorry. It's not going to turn on until I get to above what, 5.7. Even at 5 volts the motor won't turn on. Let's go up to 5 volts. There you go. Because remember, your input voltage needs to be higher than your expected output voltage. So 5.4 still not on, should go on 5.6. There you go. Okay, and then so I expect it to speed up a bit up to 6.5. Okay, and then now from here you shouldn't hear any difference in the speed of the motor. The motor shouldn't be getting worked more, nothing. Any additional voltage that I increase this to now will be dropped across this voltage regulator, and then the voltage regulator is going to heat up and eventually you'll be able to cook with it. So I'm increasing it, still going up, and the motor is staying at the same speed. At this point now, if I was sticking in 12.6 volts here directly to it, I think my motor would be dead. Now if I touch this, I expect the voltage regulator to be quite hot. It's warm. Go up to 15 volts. Still warm, but I can touch it. Oh, 17 volts is getting hot. Okay, so that's quite hot now. But look at this. So it doesn't. The great thing is, like, if I have a solar panel, if I'm using a solar panel and my voltage throughout the day is changing on my panel, cloud comes over it or whatever else. If I'm using a 12-volt solar panel and I just need to drive, for example, my Raspberry Pi camera from a solar panel, then I just stick one of these in between it, and then it's going to keep that 5 volts constant. And then that way, as my voltage is changing throughout the day or whatever, it's going up, it's going down, it's going up, it's going down, my motor here or whatever I'm using on the output is staying exactly the same. Pretty cool, right? Alright, so I've also got, turn this off. I've also got, if I can show you here, some of these are faded, but some aren't. So I've got the 78112 and the 78. This one's completely faded. This is the 7810. So this one outputs 10 volts. This one outputs 12 volts. So what I'll do is let's upgrade my little motor, because I don't want to stick 10 volts and 12 volts in this diddy little motor. This is from the Aliexpress Arduino kit. I'll upgrade it to a 12 volt fan. Okay, so let's do the 10 volt one first. So just pull this out, put the 10 volt one in its place. So now I'm expecting the fan will probably turn on, about 5, 6, 7 volts. So with the 10 volt one, I'm expecting the voltage to be 9.9 volts at the output. So let's just turn this on now. So my fan's turned on, 6 volts. So 9.2 volts. Okay, here, 10 volts. So what you can see is my current is going to rise until it reaches a certain point. At that point, when it stops rising now, that's where, now the regulator is just fully working now. It's fully on and it's receiving enough voltage. So 10 volts won't be enough, even though this is outputting 10 volts. It should be like 10.7 or something like that. So wait, I missed it there. 10.7, no, it's still more. 11. There you go. Okay, so it was about 11 volts. No, it's still going up. Okay, there you go, stop. So 250 milliamps, which was at 12 volts about. Okay, so I'm expecting at 12 volts to have 9.9 volts. So let's check that. Oh, you guys can't see it. 9.9 volts. If I increase it, 9.9, 9.95. Keep going up. 9.9, and you can hear as I'm increasing it, my fan isn't going any faster. So 22.6. Yeah, 10 volts. So you can see that it's working perfectly. So let's, I'm guessing it's gonna be hot now. Ah, yeah, basket, it burnt me. Not like bad or anything, but it's hot. Oh dear. Alright, we'll give that 10 seconds and then we'll whack in the 12 volt one. But you can see these voltage regulators are so much easier. If you watch my other videos where I was, combining Zener diodes with transistors, putting it together, that was just the learning process, so I can figure out how all this stuff works. But it's just so much easier to just obviously just chuck in these ICs. It's still hot. At least actually my Zener die did burn me. This thing's bloody hot. Ah, you basket. Alright, so let's chuck in the 12 volt one now. And you can get these, 18 volts, 20 volts. They come in all different output voltages. So, okay, we'll go again. Let's crank this up. So, .9 volts is outputting 11 volts. So this one's not fully working yet. That's only 11 volts. We're expecting 12. And you can hear my fans going faster there. Are we at 12 volts yet? Still not. 15 volts, still not enough. Okay, 16 volts. 11.89. 11.9, there you go. Okay, so it took quite a lot of voltage there, quite a bit above. So I wanted 12 volts at the output, and I've had to put what, over 16 volts in order to get a decent 12 volts. You guys get the gist. This is how voltage regulators work. I love it. I think this stuff is absolutely brilliant. In the next video, I'm actually hoping to go on to a variable voltage resistor, which is the LM317T. So hopefully I can get that done. I'm just figuring out now how that works. I figured out this stuff yesterday, so yeah, I think this is all pretty cool, man. I'm loving it. If you guys enjoyed it, leave a like. I've been getting like some emails and messages on Instagram of people asking me for what I recommend. I think when it comes to like learning the basics of all of this stuff, I think it's all very tricky. Most of the stuff online is quite complicated. They seem to describe everything in the most complicated manner possible. So if you guys know of any material that is helpful for absolute, like, you know, beginners, but, you know, like not a beginner so that he can learn Ohm's law, she can learn Ohm's law, so that they can actually like learn about MOSFETs, voltage regulators, PWM ICs, you know, all this kind of stuff. If you know of material, could you chuck it in the comments? Because I get asked it, you know, at least once a week for people asking me for material. And, you know, the only thing I generally recommend the electronics-tutorials.ws, and then I recommend the Make Electronics books, which you can get for free on the PDF versions. That's kind of the two things that I recommend. Other than that, you know, I find it difficult to learn from any material, really. Like this video here takes me like 3 days, 4 days to make, because of how long it takes me to just understand this data sheet and what all the things mean. And I have to pass through the information that I do and don't need, and it's all very complicated. Like most of the videos that involve this stuff will go through all of the maths of everything, and yeah, that's just not my style. So anyways, cool. Sorry for rambling. I'll see you guys in the next video. Take care. Bye bye.